Okay guys, we are back and we're looking at the overhead projector, and this is what the TI-84 calculator looks like. And what we're going to do, because we were given some data, okay, based on Rupert's forest, okay, we're going to use the stat button right there. See the stat button? Okay, that's it right there. So let me just show you this in the overall picture of the calculator, okay? And this right here is our stat button, okay? So we're going to press the stat button, and here's what's going to pop up, okay? What's going to pop up is, okay, let's get that up. Ready? Here we go. Let's make sure this is nice and visible. Okay, when we press the stat button, we go stat and then we go edit, okay? And you see we have a column. This column here is for the inputs, and your second column here is for your outputs. So remember we were given some data. We said after 7 days, so 7 would be one of our inputs, okay? And our output, the pair, the matching Y for 7 days would be 369. So we go over to the right column and type in 369. So after 7 days, 369 trees. Input, output, X, Y. Okay? So what's the next set of data? Well, we have after 20 days, okay? So we go 20 days, our output was, we hit enter, and we go over to this column. What's matching 20? Do you remember? Yeah, it was 20. We had 590 trees, exactly. Okay? So we enter that data. Okay, and watch how we had to go through a lot of steps to figure out the function, the y equals mx plus b form function. But watch what the calculator does for us. This is why this calculator could be our best friend here. We go stat, we go calc, and because this is a linear function, we go down to linear reg, lin reg, okay? And you see where it shows here, ax plus b, okay? They don't use an m. They just use ax plus b, but they're letting you know, hey, we're going to give you that in mx plus b form, ax plus b, okay? So we hit enter, lin reg, oh, wait a minute, hold on, stat, calc, enter, guess, there we go, okay? Y equals ax plus b, a is 17, they even point that out to you, and b is 250. Okay, so if we put that all together, do you recognize the function here? Do you recognize that this is exactly what we ourselves calculated by hand? Okay, and I'm very proud that we did it by hand, but of course this is nice also. It just took about, 1 minute to get the formula. So we now have our formula, y equals ax plus b, a is 17, b is 250, so y equals 17x plus 250. Okay, how can we now use that on the calculator to answer our questions? Okay, well, we already answered the slope problem. How many trees was he planting each day? We answered the B problem. How many trees did he start out with? Okay, so that answers the first two questions. And if we go to the Y button, the function key on the calculator, and I'll just show you that one more time. Here's our calculator. Okay, we use this a lot. The function key is really important. If we look at the calculator here, and let's just go up a little bit closer here. You see that Y key right there? Y equals? Yeah, that's our function key. So that's the one we're going to press, and we're going to enter in the function that we figured out here, okay? Okay, the function Y equals 17x plus 250. Okay, so let's go back. That's our function key, and here we go. Let me get back to that now. And I just want to make sure this is all going to fit nicely. Okay? Okay, that's great. Okay, so let's put this back up there. And here we go. Okay, nice and sharp. And, okay, so what happens when we press the Y button? Well, we get right here, Y1. You see the blinking cursor? It's asking you, hey, why don't you put in the function that you want me to graph for you? Okay? So that's exactly what we're going to do. Okay, so let's put in our function, and like we said, the function is y equals 17x plus 250. Okay, there it is. Now watch what happens. We're going to graph this, but first we're going to change our window. We see that it starts out at 250, so we want to make sure we can see that 250. So we go to window, and we go to y max. 800 is perfect. We could even go with 600. It's not, no, in fact, let's make it at 1,400 actually, okay? 1,400, and the number of days, we don't know, but we'll put x max at like 60, okay? So watch what happens when we graph, okay? Nice. We could even go up by, if the y max is 1,400, we could go up by hundreds. It doesn't matter, it'll just change a little bit. You can see now. There you go, every 100 trees, okay? There's a graph of Rupert's forest, the trees over time, okay? But if we want to get some accurate, exact information, okay, watch what we can do. We can go to trace, and we can see some pairs on the bottom. You see on the bottom where it says when x is 25, y is 675. You see that? Great. What about when x is 30? Because wasn't that one of the questions? How many will he have after 30 days? Well, we can pop in 30 with the trace button, hit enter, and what's our y? It says 760. So when x is 30, y is 760, and the calculator does this all for you. It's a really nice setup. Okay? Really quick. How many trees will he have after, let's say after 70 days? Well, we can just pop in 70. 70, enter, and don't forget, it's not showing it because guess what? The graph wasn't made large enough to show that many days. So we go to window, our x max is only 60, and we're asking about 70. So let's change that to 100. Okay, so when we graph it again, okay, now we could go to trace and ask about 70 days. That is 70 days, enter. There we go. How many trees is he going to have? 1,440. Okay? Now, the very last question said, when will the forest have exactly 1,100 trees? Well, we can go to second table, okay? And that's also on the calculator, second table. And I'm just going to press that now. You guys are familiar with that. Second table. And you see the inputs and the outputs? X, Y, X, Y. So we want to know when will he have exactly 1,100 trees? Well, these are the days, and these are the number of trees. We're looking for how many trees? 1,100. So let's keep going down, 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 down. Almost, almost, almost. There we go. Boom, we hit it. How many days did it take, or what's the input, x, to get an output of 1,100? Okay? X is the number of days. It took 50 days to get 1,100 trees. So that's how we can use technology to answer all those questions that we answered before algebraically. Okay? So, let me turn the lights back on. Okay, so it's wonderful to do it, to be able to do it, to solve these problems algebraically. It's awesome. But to be honest with you, from here forth, you're probably going to have technology at your fingertips. So it's a wise idea to be able to use it. Okay? So definitely algebraically and using technology. Why don't we say you do it algebraically to give your brain some work and solve a problem. Use your algebra skills, the wonderful skills that you learned. Okay? And use technology to check your work. Okay? Of course, if you're taking a test and you have technology and you have time limits, well, you're probably going to want to go right to the calculator. And I've experienced that myself, taking some important tests as well. So this is a great tool, and this is just one type of function, the linear function. But of course, we're going to be working with the calculator, and we have been with quadratic functions and polynomials and other types of functions. Okay, so that's our lesson, the magic forest. Signing off.